Simultaneous equation is what we are doing today, and from here we can see that there are a few methods of doing that. We see the substitution method, the elimination method, then we can use matrices, we can use graph. So simultaneous equation is a kind of equation in which we have two unknowns and we have two different equations, and so we can solve them using any of the method. We are starting with substitution method given the question we are given here. And so from here we can decide to say that looking at the first equation, 2x plus 15y equals to 12, and then the second one like that. So from the first one we will try to make x the subject of the formula. So that means we can take plus 8y to the other side to become minus. Then to remain x, we divide both sides by 2, and so this is the value of x we are substituting back into the equation. And so, having gotten that from equation 1, we substitute back into equation 2. So, wherever I see x in equation 2, I replace it with the value of 12 minus 15y over 2. And so, having done that, we see 7 into the value of x, and then opening the bracket, we get 84 minus 105y. Of course, we can see that the value is fractional. The LCM of this fraction is 2. So we can use 2 to multiply both sides. And if we do that, we will just discover that the value of the first one multiplied by 2, 10y multiplied by 2, 17 multiplied by 2, that will give us a linear equation. And so from the linear equation, we can collect like terms and then find the value of what is left. Then divide both sides by the coefficient of y that we have. And so in the long run, we'll discover that the value of y is going to give us 50 over 125, and that will give us 2 over 5. Having gotten the value of y, we substitute for y in the equation of x, and so we know that x is 12 minus 15y over 2, and of course y is now 2 over 5, so that becomes 12 minus 15 into 2 over 5. And so when we open the bracket with 2 over 5, you discover that 5 will divide 15 3 times, and so we are left with x equals to 12 minus 6 over 2, and x equals to 3 when we divide 6 by 2. So we look at the second equation, and we are still dealing with substitution method. We can see equation 1, 5x minus 4 equals to the value there, and then x minus 9y equals to the same value we have there too. So substituting in equation 2, we are making x the subject. It becomes minus 53 plus 9y, and of course that can be written as 9y minus 53. So we are substituting that into equation 1 since we got that value for x from equation 2. So substituting back into equation 1, everywhere we can see x. This gives us a linear equation. Expanding the bracket, we get 45y minus 4y equals to, and then minus 265 equals to 22. So if I collect like terms, I will discover that I get 41y equals to 287. So y is going to give me 287 divided by 41, and y is going to give me nothing less than 7. So the next thing to do is to go and substitute for the value of y in the equation of x, which is 4y minus 53. 9y minus 53 rather. So we put 7, the value will give us 10. So in this one as well, we have to find the values of p and q respectively. Still using substitution method. From equation 1, we have, using q as the subject of the formula, we are going to get 23 minus 2p, and so that gives us equation 3. And so from there we can substitute the value of 3 into equation 2 of our choice. And so doing that, we get another linear equation to which we can collect like terms, and then we can have the values as we have seen, p equals to 10. Now substitute for p in equation 3, which is the equation for q, 23 minus 2p. So fixing 10 into the place of p, 23 minus 20, q equals to 3. Now we move on to elimination method. As the name implies, it means that what we do is that we cancel values out, when they are equal. So using equation 1 and equation 2, we want to eliminate y. The first y is plus, the second one is minus, so we can add them together so that they can cancel out. And so doing that, I'll get 11x equals to 55. Divide both sides by 11 and x equals to 5. We are not substituting here, we eliminate again to get the value of x. And you can discover that x has different coefficients. So what we do, we exchange their coefficients in multiplication, and then we get the same values as coefficient of x. 24x for the first one, 24x for the second one. So seeing that both 24s have the same positive sign, we therefore subtract them from each other. And so subtracting 2 from 1, we can have 24 minus 24, and then have plus 8 minus 3y equals to 192 minus 93. So having done this, we get 11y equals to 99. And so 11y is going to give us 9 when we divide it by 11. So moving to the next equation, of course we did this question the other time using substitution. Now let's redo it again with elimination method. So we discover that the coefficient of x is 1, the other coefficient is 5. So we cross multiply their coefficients. And so we are going to get the same coefficient for x, 5x, 5x. But remember, they have the same sign. They are both positive. So we can subtract the two equations from each other. And so subtracting them from each other, 5x, we take out 5x. Then we have minus 45, minus into minus 4y. And the same for the other side. So that will give us minus 41y equals to minus 287. Divide both sides by minus 41. What do we get? 7. And so we are going to eliminate to get the value of x. And that means we will do that by eliminating y. And so we can check their coefficients and see that they are different. So we cross multiply their coefficients. So we use each of their coefficients to multiply the two equations given. And having done that, we get the fourth and fifth equations respectively. And so, of course, we can see they are both negative. So it means we can subtract them from each other. Remember, when the value you want to eliminate have the same sign, what you do is that you subtract. If the signs are different, you add them up. And so in this case, you can see that's what we did. And the value of x gives us 10. Thanks for watching.